Welcome to lesson 2.5, where we will review what area is and talk about estimating it. So first off, let us review what area is. So first off, we're going to be talking about rectangles. It's the basic shape and it's what area is actually based off of. So what it is how much space something takes up. I'm going to type this because you guys all know my writing is brutal. So how much space something takes up. How much space something takes up. Right. Another way of looking at that is how many squares. And that's super important, the idea that it's squares. Cover a surface or a space. Alright? And when we're talking about rectangles, area equals length times width. Alright, and that should all be pretty well reviewed. So I'm just going to move this so it doesn't cover up my rectangle there. So, if we're looking at my rectangle over here, I want to know what the area of this thing is. So we can do this a couple ways. One, we can just count how many squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Right, so I know right off the bat, just by counting, that my area equals 35 squares, or 35 units squared. I don't know if they're centimeters, inches, feet, whatever. All right, so those 35, I'm going to say units squared. Oh gosh, no, stop that. Units squared. Now, if I'm too lazy to do that, or if my rectangle is too big, just say, put that back to where it was. If I've got a really large rectangle, I do not feel like counting that much. I'm just going to count the edge length. 1, 2, 3, 4, 5. And my other length. 1, 2, 3, 4, 5, 6, 7. Alright, so my area is length times width, which is the same as, well, my length was 7, my width was 5. And 7 times 5 is 35. And again, I don't know what these units are, so I'm just going to call them units. Units squared. Alright, same answer, no matter how you do it. Alright, so that's the quickest review ever. Now, I said we'd talk about estimating. So we talked about reference before. This is something concrete you can use to estimate. So for instance, 1 inch squared is about the same size as a postage stamp, but since nobody uses mail anymore, chances are you're more likely to have a thumb with you than you are to have a postage stamp. Right? So your thumbprint is about how much area 1 inch squared is. So I want to put down some of these, and I want you to add your own. So I want one more from you on this chart for each unit. So 1 foot squared, that's about the same size as a textbook. Right. A yard squared, that's about the size of a large TV, a good sized one. I'm talking like 50-inch maybe. That's pretty close. A millimeter squared, that is tiny. That's about that big. So it is, if your pen point somehow made a square, that's how big a millimeter squared would be, give or take. A centimeter squared, my personal favorite. If your thumbprint is an inch, your pinky is a centimeter squared. Right. So I like to think of that as your pinky fingernail. Right. That little fingernail, that's about how big 1 centimeter squared is. And a meter squared, that's actually pretty close to a yard squared. These are very close. So again, a large TV. Now remember, I want you to add one more of your own because you're going to remember ones that you came up with better. If you're questioning yourself, please ask me and I'll tell you if they make sense or not. All right, let's do a couple examples. All right, example number 1. A room measures 3.05 meters by 3.96 meters. I want to just estimate the room's area. All right, so 3.05, that's pretty close to 3. And 3.96, that is just a hair under 4. All right, so this is pretty close to 3, and this might as well be 4. So my area is length times width. So if my length is pretty well 4, my width is pretty well 3, my area is going to be pretty close to 4 times 3, which means my area is going to be 4 times 3. That's about 12. All right, so it's going to be pretty close to 12 meters squared. Now, just in case you didn't trust me, we're going to calculate it now. And we're going to go to 2 decimal places. All right, so my area, using the exact values this time, is 3.05 times 3.96. All right, let's jump to our calculator. So 3.05 times 3.96 equals 12.078. So I went to 2 decimal spots, so that's going to be 12 point, round that up to 12.08. 12.08 meters squared. Look how close we were with our estimate. And this is way quicker. I didn't need to go to a calculator or anything. It was just bam, done. 3 times 4 is 12. And we're so close. This is a great way to check your answers, is by estimating. That way you know if your answer makes sense. All right, one more example. Okay, the top of a rectangular couch cushion is 23 inches by 26 inches. So Joe wants to purchase enough material to cover the cushion. So first off, let's estimate the area in square feet. First you'll notice, hey, these are in inches. That's okay. Remember, 12 inches equals 1 foot. All right, so 23 inches is pretty close to 24 inches. Close enough. So 24 inches is the same thing as 2 feet. So since we're estimating, so 23 inches is pretty close. So once you put the dot over it, that means approximately equal to. Okay, so it's pretty close to 24 inches. It might as well be. 24 inches, well, that's the same as 12 times 2. 12 inches per foot, so that is 2 feet, give or take. Oops, there's not supposed to be a dot there. Alright, so that's 2 feet. And 26 inches, well, that's also pretty close to 24. I'm trying to pick nice numbers. I like to do easy math. Right, and that's, again, 2 feet. So my area, if I'm estimating, length times width, well, 2 feet times 2 feet, my area is 4 feet squared. Right, that's my estimation. So let's calculate it, see how close our estimating was. So if I'm going to calculate this, what I'm going to do is I'm actually going to calculate my area first. I'm going to do it in square inches. So my area is length times width again. So that is 23 times 26. Jump to my calculator. 23 times 26 equals, bam, 598. 598. And you're like, whoa, 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 we estimated 4 and you're at 500? No, don't worry. Remember, this is in inches squared. Square inches. I want my area in square feet. That's what this is in, feet squared. Right, so now I have to do a little bit of conversion. So I'm going to use my skeleton equations. Okay. Now, just as a side note, in case you don't have your formula sheet handy, 1 foot squared is 144 square inches. Okay. So my first number comes from my question, 598, and that was in inches squared. Second number comes from my formula sheet, 144, again, inches squared. And since I'm trying to change, whoops, sorry, that's not inches squared. And we're trying to change into feet squared. So since I'm changing into a bigger unit, my number's got to get smaller, so I'm going to divide. So 598 divided by 144. 4.15. Right, look how close we were. So depending on the situation, estimating might be good enough. So, like I said, it's an awesome way to check your answers once you've been working. Alrighty. So I know this one's a self-check question, but I just want to show you what I mean, what I want you to do for this one. Alright, so when you're estimating an irregular shape like this, the best thing to do is quite literally count. First thing you want to do is count how many whole squares there are. Right, so keep track of all the whole squares. Okay, all those throughout the shape. Then you're going to want to look at all the pieces. So you notice, hey, I got a half here and a half here. If you combine them, these will make one. So these ones will make one square. All right. And this one, you're like, well, it's only missing a sliver. And then you're like, hey, look, this one's only including a sliver. So these two, they're going to make one together. So you're going to keep track that way. So keep track of all the full ones, and then start keeping track of, try to put pieces together to make one. And you're just going to count them and keep track. Okay, and then do the rest of the self-check questions. Again, check your answers, ask questions if you have them, and keep having fun with your math.